Okay, so we've been talking about the ratios and the proportions, and we've solved some proportions last week. I want to take a look today at probably the biggest application of that, and that is in similar figures. And what we're really talking about there is if we take a shape, thank you, like this, and if we either reduce or enlarge that shape, but keep all of the dimensions proportional, basically, like this. So now we've just enlarged that triangle. And if we know the dimensions of the original triangle, let's say that this is 18 inches, 6 inches, and 16 inches. And we know that the second triangle is an enlargement in this case, or it could be a reduction in other cases. And we know which sides match up. And to know which sides match up, we usually look at the angles. We could probably guess, but we'll indicate that that angle is the same in each triangle. And then we'll indicate this angle is the same. And all we need to know is 2, because once 2 are the same, then the third one has to be. And if I were to tell you that this side over here is 9 inches, we can now find the other two sides. I call them X and Y. We know that 6, when we went, the side that's 6 inches long, when we went through the enlargement, became 9 inches long. So we have a relationship there. So that's a ratio, 6 to 9. Now we could reduce that ratio if we wanted to 2 to 3, but we don't have to. Now we need to look at which side do we want to find. We need to find X and Y. We need to pick one of them to find right now. We'll pick X. So we're going to use X, and we're going to use that known relationship of 6 to 9. You might call that a reduction factor, an enlargement factor if you want to. And we're going to plug in the missing pieces. Where's the X going to go? Is it going to go on top or bottom? Yeah, that's the thing. You got to look at what is it linked to. We have the 6 and the 9. The X is going to link to the 9 because it's in the same triangle as the 9. On top then would be the 16. And now to find X, we just cross multiply and divide. 9 times 16 divided by 6 is 24. So X is 24 inches. And we'll do the exact same thing to find Y. We still have that 6 to 9. That relationship stays the same. Y now still goes on bottom because it's still from the same triangle as the 9. And above it would be the 18. That's the side from the other triangle that relates to the Y. 9 times 18 divided by 6 is 27. So Y is 27 inches. It doesn't have to be a two-dimensional shape. It can be a three-dimensional shape. We might have something like this. Pretend my artwork isn't horrible, and that actually looks like a pedestal type deal. We'll see if it'll let me enlarge it without totally messing it up. Oh, not too bad. Now, if I'm looking at something like this, and let's say that I am told that the base of this one here is 16 millimeters. And this one over here is, well, let's go 30 millimeters. And the height of this one, we'll say, is 18 millimeters. We want to know that height. And let's say the top of this one here is 6 millimeters. And we want to know that dimension. Again, we have to know that one is a reduction or enlargement of the other. And in this case, I'll tell you that that's the case. The word that you're going to look for that usually indicates that is the word similar. If you're told that two figures are similar, that means one of them is an enlargement of the other or a reduction of the other. So now we need to look for, is there a side here that we know the dimensions of in both of the figures? There it is. It's that base. There's 16 to 30. We can leave it as 16 to 30, or I'm going to do this just to make it a little easier to work with. I'm going to divide by 2 to make that an 8 to 15 ratio. It doesn't matter. I could have left it at 16 to 30, but I'm trying to do most of my calculations in my head right now, so I'm making it as easy wherever I can. Now let's find H. So I have 8 to 15. Where is the H going to go? It goes on top. It is from the same figure as the 16, which is where the 8 came from. What's going to go on bottom then? 18. Now you notice the 18 has a relationship in both directions. It is the height, so it relates to the h. It's also from the same figure as the 30, so it relates to the 15. And you notice in these proportions, it's very important. You must have a relationship in both directions. The 8 relates to the 15 because, well, those are from the bases. But it also relates to the 8 because they're from the same figure. So we'll fill in the 18 here. And we'll cross multiply and divide. 8 times 18 divided by 15. 9.6, you said? Perfect. So that is 9.6 inches. To find x, well, we still have the 8 to 15. X this time goes on bottom, because it's from the same figure as the 30, so that's where the 15 came from. On top will be 6. So we have 15 times 6 is 90, divided by 8 is 11.25. Any questions? For you guys, why is this so important? Well, no problem. Well, one of the biggest things that you're going to use this for is for your scale drawings. Most of your drawings are a 1 to 8 scale, or actually they call it a 1/8 scale. It's 1/8 to 1, which is the same as a 1 to 8 scale. So what that means is every dimension on your drawing has a 1 to 8 ratio, or 1/8 to 1 if you want to do it, of the drawing to the actual dimension. So if you're looking at a drawing and there's a dimension that isn't labeled. Let's just have a drawing like that. Let's say there's a dimension right here that isn't labeled, but you do know that it's a 1/8 scale, or a 1 to 8, or 1/8 to 1, whichever way you want to look at it, scale. You can bring out your ruler and you can measure that on the drawing. And let's say it measures on the drawing to be 1 7/8 inches. To figure out what that is actually on the part, you have the 1/8 to 1. Where's the 1 7/8 go? It goes on top. 1/8 is the drawn, and the 1 7/8 is from the drawing. So then x goes here. The actual dimension, 1 times 1 7/8 divided by 1/8, should be 15. So in real life, that's 15 inches. Yeah, that's a big piece.
I see the premise behind it, but in actual industry, is there a lot of that type?
Well, do you guys have a scale ruler that you guys purchased in your kits? They actually make a ruler. It looks like a triangle. When you look at it from the end, it looks something like this. I don't think I have one in here. Let me see if I got. Okay, so let's go the other direction. Let's say you have a part and you need to draw it, and you have a dimension here that is 3.5 inches. And you need to know how long to draw it. And we're going to use a 1/8 scale again. Where's the 3.5 going to go? Bottom. Because this is the actual, is represented by the 1, and the 3.5 comes off the actual. So now to find this missing dimension, I'll put my x in there. 1/8 times 3.5 is 7/8. Divided by 1 is just 7/8 an inch. What do y'all think? Okay. Well, in that packet, the ratio and proportion packet, starting on page 229, I'm just going to give you a few of them today, 41 to 45. So just 5 problems there. We'll talk more about this stuff tomorrow. We'll hit the missing dimensions and stuff pretty hard tomorrow. Actually, tomorrow we'll talk a little bit about percents as well. Because percents, just a review, because we know we did last semester, but Percents hit this ratio and proportion topic as well. Then we'll look at three-dimensional parts and things like that.